Five. Okay, so first of all, what we're doing is we're going to use the unit circle to evaluate sine theta and cosine theta. Okay? So what we have to do for sure is write this down. We know that sine of any angle is always the y value on the unit circle. It's just the y value because it's y over r, but the radius is 1. It's y over r, opposite over hypotenuse, right? But since the hypotenuse is 1, it's just the y value. And we also need to remember that cosine of any angle is always equal to the x. It's the x over the r. It's the adjacent over the hypotenuse, but the hypotenuse is 1. The adjacent is the x value of the coordinate. Okay, so it's super easy, right? Is this all making sense?
I mean, I guess.
Yep. And Evan, this is kind of cool because you kind of missed this. Well, no, you didn't miss it. You were here. It was out geometry you missed. Yeah. You saw this last year. Yeah. Okay, so sine of 45. Exactly. So I go to 45 degrees on my unit circle. There it is. I'm looking for sine, which is the y value. Square root of 2 over 2. That's my answer. Right? Square root of 2 over 2. Bam! Cosine of pi thirds. Mode change? No, we're not going to change the mode in our calculator. We're just going to go to the circle. Pi thirds, which is the x value, is 1/2. Bam! Easy, huh? Sine of 2 pi thirds. 2 pi thirds is there. And I'm looking for sine, which is the y value, which is? That's it. Square root of 3 over 2. Bam! Now, negative 30 degrees. Where's negative 30 degrees?
330.
Yep. It's right there, right? And I'm looking for, is it sine or cosine, Landon?
I'll be back.
Is it sine or cosine, that example?
So,
Is it sine? Y value?
cosine.
Cosine. So x value is square root of 3 over 2.
Wait,
Right?
how do you do the negative?
Negative 30 degrees is right there.
Oh, it's just.
Do you agree with negative 30 degrees being there? Because you, instead of rotating up 30 degrees, we try to rotate down negative. So, and it's cosine, so it's square root of 3 over 2. What we're looking for is really cosine of 330 degrees, which is the same thing as that, okay? Bam! Sine of negative pi thirds. Where's negative pi thirds? Sine of negative, well, positive pi thirds is this much rotation. So if we go backwards, negative pi thirds would be here, right? And cosine is the x value. So it's just one here.
Wait.
Okay, I'll do it again, Zoe. So, you ready? Pi thirds is this much rotation. Now, you got your car. Put your car in reverse, rotate your tire the same amount, and put your right to there, right? Does that make sense? And cosine's the, are we doing cosine?
Uh-huh.
So cosine's the 1/2, right?
No.
Oh, we're doing sine?
This-
Sorry. Sine is the y value, which is negative square root of 3 over 2. Yeah, negative square root of 3 over 2, okay? Sine is 7 pi thirds. Now, before I do this, 7 pi thirds is not on my circle. I got 5 pi thirds, but 7 pi thirds is the same thing as sine of 2 and 1/3 pi. Let me just write that down, okay? Okay, 7 thirds.
No, I'm still confused on number 5.
Okay, you ready? Let's rotate to pi thirds.
Yeah, but
Now let's
then,
go backwards here.
yeah, and it's 1/2.
Well, I think we're doing sine, aren't we?
Yeah, and sine is 1.
And that's in okay, so back to this one. So 7 thirds, 2 and 1/3. Do you agree with that? So we're going to go around the circle, 1 full. Okay, watch. I'm going to go around the circle. Here's 2 pi, right? And then 1/3 puts me there. So 7 thirds is 2 and 1/3, so it's right there. And what am I looking for? The sine value, which is the y value, square root of 3 over 2. See how I did that? Want me to do it again? Okay, Zoe. 7 thirds is not on my circle. But 7 thirds is the same thing as 2 and 1/3. Okay, if I just reduce, 3 goes into 7, right? So 2 and 1/3. So watch, I'm going to go all the way around 2 pi, and then 1/3 more puts me right there. So on that angle, See how the reference angle works now? This is why we talked about the reference angle, because it's that angle we want. And if I want the sine value, I want the y value, which is square root of 3 over 2. Okay? Now, reference angle. Well, okay, if I want to find a reference, first I'm going to draw a picture, okay? And I know 100 degrees is right about here, okay? There's about 100 degrees, okay? The reference angle has to be this right triangle here, okay? So I know that it's 180 degrees all the way around, correct? Halfway around is 180. So this angle here would have to be 80 degrees. So my reference angle is 80 degrees. It's the angle that makes the right triangle flush with the x-axis. Make sense?
Uh-huh.
Okay. 320. So let me draw a picture of 320. 320 is luckily is on my unit circle, but 320, well, close. 320 is right about here. Okay. So 320 degrees is all the way around to here. There's 320 degrees. Okay. Now, I know that all the way around is 360 degrees, right? So this angle here would have to be 40 degrees, right? And then the right triangle I'm looking for is this right triangle, so my reference angle is the 40 degrees. And the reason we need that is because you won't do trig with a 320 degree angle. Even though your calculator does, it's really not doing it with 320 degrees, it's really doing right triangle trig with the 40. That's why the reference angle is important. Okay, negative 120 degrees, let's take a look at that one. Okay, so negative 120 degrees is, well, if 120 is here, negative 120 degrees is right about here, okay? Negative 120 degrees, right? The right triangle I'm looking for is sitting right there, correct? So what I'm looking for is, well, that's 180, then that angle's got to be 60 degrees. It's a positive angle because we're looking for right triangle trig. It's always a positive angle because we say, okay, we need to find a right triangle. Does that make sense? Positive angle. We're just trying to create a right triangle. That's what we're doing. And the reason we do that is because when we do trigonometry, even with the unit circle, we're really doing triangles. Remember how I built all the triangles? Okay, 10. It's radians. No big deal. I can do this. Same kind of stuff, right? So if I draw a picture, 3 pi fourths is right there. Okay? And you can check on your unit circle, but it really is. So 3 pi fourths is here. Okay? The right triangle I'm looking for is here, right? So then here's my angle theta, but in radians, remember this is pi, this is pi halves, so this is going to be a pi fourths, okay? If you need to change these to 2 degrees, you can, if the radians confuse you. But if it bothers you with the radians, then you can say, well, this is, for my unit circle, that's 135 degrees. For a unit circle, that's 135 degrees, right? So then this would have to be 45, which is, look at your circle equivalent to pi fourths, okay? That circle can give you everything, all right? How am I doing? Am I going too fast or okay?
You're good.
Okay, 11 pi 6. Let's take a look at 11 pi 6. So if I draw a picture, and it's even on the circle, 11 pi 6 is, right? 11 pi 6 is here, okay? It's all the way around to here, okay? This is 2 pi, right? And this is my 11 pi 6 all the way around to right here. So then the right triangle I'm looking for is this right triangle. The theta I'm looking for is right here, which is a pi over 6. Now, again, if the radians bother you, then you've got your circle. You know that this is the same thing as a 330 degree angle, correct? Which is your circle, right? Which means this has got to be 30 degrees to make the full 360, right? And you see the 30 degrees, right by the 30 degrees, is the equivalent pi 6. Okay, is that easy? Are you good on that? So your circle can help you a lot, right? Yeah, Emily, Celeste, I'm sorry.
Why are you doing this?
I just can't, I don't know. I've known Celeste forever, I guess, right? So,
Will you accept us doing degrees instead of minutes?
yeah, I would. Okay. So then, 12, negative 2 pi thirds. Now, negative 2 pi thirds for my circle. Okay, ready? I'll do it again. Positive 2 pi thirds is here, right? So let's get in the tractor. Let's call it the tractor, okay? Okay, so we got to back the tractor up that much rotation, so we're going to back the tractor up to right there. So we're going to positive 2 pi, we're going to go negative 2 pi, puts us right there, correct? That's my spot. So it's my angle. So let me go ahead and draw that in. So it's right about here is my angle. Hold on, I got too many pins. Okay, so that's my negative pi, 2 pi thirds. So the right triangle I'm looking for is right here, right? So if you do degrees, right, if you do degrees, it's the same thing as a negative 120 degrees. Negative 120 degrees, which makes this 60 or pi thirds. That's going to be pi thirds.
What is 9?
This what?
What's question 9? What is it?
Question 9 was a 60 degree angle. That's a right angle. Sorry, that's a 60, okay? How am I doing, okay? So the reference angles are important because when we do even circle trig, the circle is really a bunch of triangles in the circle. So we do right triangle trig, we need to use the reference angle, right? Okay, moving on. Ready to turn the page or am I going too fast? All good? All right, now, if sine is 1/4, find cosine. Now there's two ways to do this, okay? First of all, we learned, let me show you two ways. We learned that sine squared of theta plus cosine squared of theta is equal to 1, okay? We learned that Pythagorean identity in our reading, right? So if we put in 1/4 here, we should be able to figure out what cosine is, right? You guys agree with that? So, I put in my 1/4. Sine squared is really that squared. So I'll have a 1/16 plus a cosine squared theta equals 1, right? Minus 1/16, I'll have a cosine squared theta is equal to 15/16, that because 1 minus 1/16, 16 over 16, 15/16. You guys okay with that? Right, I mean, I just show the fraction. Okay, and then what am I going to do next? Square root, right? How many answers? Square root 2, so I square root. So my answer is going to be that my cosine of theta is equal to plus or minus the square root of 15 over 4. That's the cosine value.
These are nice.
Yeah. Okay, number 14. Okay. A 30-foot Ferris wheel makes a revolution in 2 minutes. If I hopped on at the base and rode for 5.5 minutes, how far off the ground would I be? Okay. So, let's just draw a picture. 15, 15, 15, 15. I'm just going to start there. You guys okay with that? 15, 15, 15, 15, right? Because the Ferris wheel has a 30-foot Ferris wheel, right? Okay. And one full revolution in 2 minutes. So that means it's going to go 360 degrees, right, in 2 minutes. So if it goes 5.5 minutes, it's going to go another 2 minutes, which will be another 360. So if I start here, it's actually a pretty easy problem. Okay, if I start here, I've gone one full revolution, right? I'm going to go another full revolution. Now I got 1.5 minutes left. 1.5 minutes left. So it should take me to right about here, shouldn't it? Okay, because what it really is 180 degrees in 1 minute. Is it 180? Oops, I got the wrong spot. So hold on. Here's 1, 2, and a half. And then a half of that. Oh, I'm in the right spot. I'll do it again. So we'll go 360, Zoe, another 360. Okay, then I'll do a 1 minute revolution, puts me to here. Half of that puts me here, okay? How high off the ground are we?
80, 180.
15 feet. That wasn't so bad, was it? Okay, let's pause the video and do some homework. Hey, did you guys learn something?